everyone, today we're looking at error in measurement and we're specifically looking at precision. If you don't use care when you're measuring, then your measurements won't be right. They won't have the true measurement of what you want to measure. There's three specific types of errors you can make when you're measuring something. One is called parallax error, and you will have heard about that in science. That's when if you're looking at something that you've measured, say for instance, a liquid, and you look at it from an angle, so here's your eyeball, here you've got your eyelashes. If you look at an angle like that, instead of straight on, you'll get a parallax error. When you look at the angle, you won't see the liquid at the spot that it is exactly. Another error that you come across is zero error, and that's when your device isn't set at zero. So if you have a look, here's my measuring scales from my kitchen, and if you have a look, when you go to start to measure, you need to turn our measuring bit so that the yellow measuring line lines up exactly with zero. So if I was going to weigh my calculator, it's about 100 grams. But if I started with the yellow line at a different spot, when I went to weigh my calculator, it would tell me a different measurement. So that's what zero error is about. It's about when you haven't put your device at zero when you started. It can be with a tape measure as well. If you don't put the tape measure at zero at the very start of where you're measuring from, you'll get a wrong error. The other thing is reaction error. So that's when you're measuring time. So that's the time for the operator to react. If I was using a stopwatch to measure how fast someone was running and I didn't press the button quick enough, then the measurement I took of how fast they were is actually wrong. So even if you get rid of your parallax error, your zero error, and your reaction error, you're still going to have a little bit of error because you can only be as accurate as the precision of your measuring device. So here's an example, if you can see this. This is from my pool measuring strips to see what different things I've got in my pool. If you have a look, they go up by different scales. So 0, 100, 250, 500, 1,000. So it's not a continuous scale there. Here it goes up 0, 0.5, 1, 3, 5. I can only be as accurate as the numbers that are on here. I can't be completely accurate because it's not going to be a number or a colour that falls exactly on the scale. So when we have a look at a device, the precision is the smallest unit the device can measure to. So if we have a look down here and it says what's the precision of these measuring devices, here we're measuring in centimetres. If we count up, we've got a 10, a 20 and a 30. That's fine. We need to see where the dashes are at. So let's see, 1, 2, 3, 4, 5. That means each of these dashes is 2, 4, 6, 8, 10 centimetres. Each dash, each of these, is 2 centimetres. So the precision of my measuring device for this ruler here is 2 centimetres. I can only be as precise as about 2 centimetres. If I was to measure, so this is 8 and this is 12 here, if I was to use this ruler to measure something and I got a number that came in about here, I know it's bigger than 8, it's less than 10, I could guess it's 9, but I can't be more precise than that. If we have a look here at this example here, again we're measuring in centimetres, but this time we've measured down to the 1 millimetre. Each of the lines in between on our measuring device there comes in at about 1 millimetre. So more accurate, I can measure to the closest millimetre here, whereas on this ruler I can only measure to the closest 2 centimetres. If I have a look at the scale here, kilometres per hour, it tells me my units are 80, 90, 100, but you can see there's another little line in between. So I'm going to the nearest 5 kilometres per hour. I'm not going up by 10s, I'm going up by 5s. Maddie, my daughter's just popped ahead in the screen there. So we'll get that out and we'll keep going. So we're measuring to the nearest 5 kilometres an hour. On this last example, I don't think you'll be able to see it, but there's a very, very tiny dash in between our numbers here. So we're measuring to the nearest 0.5 of a degree. So that's what precision is. It's about looking at the tool that you're using to measure and looking at how close you're able to get when you make your measurement